would like to introduce the speaker of the second annual lecture. Professor Michel Danino, born in France in 1956, has been living in India since 1977. A student of Indian civilization, he has authored papers and books in French and English. Recent titles include The Lost River on the Trail of Saraswati, a multidisciplinary study of the Vedic Saraswati River. Other books include An Indian Culture and India's Future, The Dawn of Indian Civilization and the Elusive Aryans is a title which is forthcoming. Professor Danino has lectured at many cultural and higher educational institutions across India, and he's currently at IIT Gandhinagar as a guest professor where he's assisting setting up of an archaeological sciences center. Professor Danino has been instrumental in us working towards setting up the center. On 5th September 2012, we had a preliminary meeting at IIT Madras where Professor Danino was present with members from the Archaeological Survey of India and the Department of Civil Engineering, IIT Madras. And that really laid the foundation for taking this endeavor forward at IIT Madras. So, Professor Danino, your talk on Harappan expertise in civil engineering.
Thank you very much. Thank you, Professor Arun, Professor Meher, Professor Matthews. It's an honor to have this second memorial lecture in this pioneering center, and to have it presided over by Professor Matthews, whom I've been lucky to know for a few years. I think this center has a bright future ahead and lots of very important projects which are the need of the day, because Indian archaeology has suffered from a lot of a lack of expertise in the way it has handled problems of heritage conservation in particular. So whatever Professor Matthews has shown us before is highly relevant, and I hope to show how Harappans dealt with, not exactly, of course, similar problems, though I will bring the problem of earthquakes very briefly on one or two occasions, but how Harappans face problems of civil engineering in the establishments of their cities. So I'm going to cover a very wide field, of course, somewhat superficially, and trying to show how in every field they were pioneers, and sometimes, in fact, they have found solutions which we could still sometimes perhaps learn from. Let me start with a very brief overview of the Harappan civilization, also called Indus civilization. Indus Valley civilization is regarded as an obsolete term for an obvious reason that, as you can see, it is the entire northwest of India, with even one side above this map in northern Afghanistan and sides all the way to Maharashtra and western Uttar Pradesh. So we cannot really speak of Indus Valley anymore. It is also called Indus Saraswati civilization because, in fact, most of the sites are located along the now dry bed of a river called the Ghaggar River in India and Hakra in Pakistan, as this is the international border, as you can see. And we have here the highest concentration of Harappan sites. Curiously, it was actually not really in the Indus, though there's a good number of them. I'll show you the figures in a moment, but first of all, let us keep in mind that this area is something like 1 million square kilometers. It's huge. It's much vaster than ancient Egypt or ancient Mesopotamia, which are contemporary civilizations. These three civilizations are Bronze Age civilizations. We are in the 3rd millennium BC. These are the dates for the, strictly speaking, urban phase of the Indus civilization. Of course, there are long developments earlier and some later, but I'm not going to talk about that because that would be too long. And so this is already a huge question mark. How does a civilization manage such a colossal area in ancient times where modes of communications are limited to the bullock cart or to boats on the rivers? So this is something that archaeologists are yet debating. But let us keep in mind we are in the 3rd millennium BC, broadly speaking, and we are going to have a look at cities like Mohenjo-daro, which is here, of course, famous, the most famous in Sindh, Harappa, which was excavated from 1921 onward, Mohenjo-daro just the next year, and we will also see a number of cities in India like Kalibangan, which is in northern Rajasthan. Dholavira is a very important city in the Rann of Kutch. Lothal is an important little town in Gujarat. There are many more sites which are being explored. Not too many in Pakistan, unfortunately, but in India, Rakhighari in Haryana is possibly the largest site located within India. Its exact area is still being debated, but it runs into possibly more than 200 hectares, whereas Dholavira is around 100 hectares. There are many more sites, especially in Haryana, which have been explored of late. So in fact, we don't yet know the final word about the Harappan, the distribution of Harappan sites. This is a temporary table which I compiled from various sources, which shows you can just concentrate on the mature phase because we are not concerned with the earlier or later phase right now. And you can see that the Sarasvati Basin has one of the largest chunks of Harappan sites, followed closely by Gujarat. But if we, of course, include the entire Indus region, together with sites in Balochistan, we get to a little more than 400. So this is a temporary figure. In fact, it should be something like 1,200 sites today if we include all the latest discoveries in Haryana and Punjab, which actually almost every month you have new Harappan sites being discovered. Now keep in mind that discovered simply means identified. It doesn't mean that they are excavated. In fact, not more than 10% of these sites have been excavated. 90% are totally untouched. They are identified simply by collecting material on the surface. And even those 10%, most of them have been very, very scantily excavated. Just a couple of trenches here or there to get the vertical stratigraphy and therefore the chronology of the site. So we must understand that our grasp of this civilization is still in its preliminary phases. And there's a lot to be discovered, and sometimes a new site can throw up totally unexpected aspects of the civilization. Initially, it was thought that Mohenjo-daro might have been a central capital, something like, you know, the early archaeologists were talking of the Harappan Empire, and then they figured a kind of emperor sitting somewhere in Mohenjo-daro. But this has been totally, I won't say rejected, but modified by so many important cities outside Sindh. And in fact, this is one of the current lines of thought among archaeologists. This is from the late Gregory Posel, who sees more regional developments, with each region having a certain stamp of its own, especially in terms of pottery and develop certain types of crafts. But nevertheless, as we will see, there is at the same time a unity, a certain amount of standardization running across all these regions. So we don't know really how the government, if you like, was functioning, what kind of overall administration was at work, but we can speak of a kind of confederation with some assurance. Don't forget also that this Indus civilization was not living in isolation. It was in touch with many other Bronze Age civilizations, especially those of the entire region around the Persian or Arabian Gulf. You see here Magan, which corresponds more or less to Oman, Dilmun to Kuwait and a few other emirates. Mesopotamia, of course, and we know that Harappan goods have been found and seals have been found in Mesopotamia. Elam, which was part of Iran itself, and then the entire southern region of Central Asia. So it's a huge sphere of interaction, as it is called. These civilizations were trading fairly peacefully together, exchanging a lot of goods and also cultural inputs. And yet, the striking phenomenon is that all of them kept a stamp of its own. They did not merge. They kept their specific individuality, and including the Harappan civilization. One of its peculiar feature was that the early archaeologists who excavated there were a little disappointed. You see, they were expecting very spectacular finds, the kind of which had been found in ancient Egypt or ancient Mesopotamia. So, of course, there were no pyramids, that was already understood, but maybe some glorious royal tombs with lots of treasures and gold and stuff like that. But then they found, as Mortimer Wheeler says, miles and miles of monotonous brickwork with almost nothing, almost no art piece, almost no hoard of gold or jewelry, etc. So it was a little bit of a disappointment, and it took them some time to understand that the genius of this particular civilization was elsewhere. And in fact, that's what we're going to discover in this talk. So this is from Mohenjo-daro. We will revisit this slide a little later. Let me start with the most striking, of course, most visible, conspicuous feature of the Harappan expertise in civil engineering, and that is the urban development. And this is where it perhaps scored over its contemporary civilizations. Actually, we are not, of course, trying to compare and decide which one was ahead of the others. One that depended on every particular aspect of their developments. So we're not in comparisons. But one thing which is immediately striking is that if you look at a plan like this is the plan for the Acropolis, that is to say upper city of Mohenjo-daro, which sits on a mound, as you can see, and this mound is actually an artificial platform made of mud bricks of something like 7 meters in height, which was meant to somewhat insulate it from the regular floods of the nearby Indus River, which in those days were, of course, much more powerful in amplitude than they are today because of number of dams which have been constructed of the river. And so you have a huge, millions and millions of mud bricks have been brought here, and then this was built over. And you can see immediately that there is an intention. There is a plan. Some people, we will never know who, call them architects, call them civil engineers, sat down and decided that they wanted to build a city exactly like this. And like this means streets perfectly at 90 degrees angles, aligned in addition to the cardinal directions. This is north, south, east, west, very precisely. And monumental structures, huge buildings, strangely, whose purpose most of the time is still uncertain. The reason is that, for instance, in ancient Egypt, you can almost, in every city, not quite, but very often, you can immediately point to the palace. You see the place where the pharaoh lived. It kind of stands out. It was meant to stand out. There was an architectural message given that, this is where the ruler lives. There is no such architectural message ever given in the Harappan world, and you never know actually where the ruler might have been really living. Somewhere here, because this is the upper part of the city, the lower part is a huge area. We'll see only a small bit of it to the east of the Acropolis. And you see here a building which we will revisit. This is the Great Bath. This is an enormous building of nearly 23 meters in width and 69 in length. Perhaps it was where the ruler lived, but we don't really know because it's just a series of endless layout of rooms. There are pillared halls here. I mean, in fact, I could show you the plan more clearly with these indications. This is a pillared hall. This is the Great Bath, and this is the so-called college. All these terms are a little bit arbitrary, including the term of granary, which many of you would have learnt in your school textbooks. And this colossal building with huge platforms, in fact, today, well, nobody really knows anymore what it was used for. There is no direct evidence that it was ever used to store grain because no remains of grains have been found there. This is the closer view of the granary with all its platform. The safest label that some archaeologists today propose is that of a warehouse, but to store what is again a mystery. It was quite enormous in size. You can see the complex of the great bath next to it. And there were all kinds of structures there to lower goods to platforms of different levels. But at the end of the day, what was being stored remains a little uncertain. These are some of these platforms here, which belong actually, strictly speaking, to different periods. They were not all of the same epoch. And there are some remains of sockets of timber sockets showing that there must have been a huge superstructure made of wooden beams over which some kind of a roof would have been laid. So this was certainly for storing something, but whether it was grain is not quite proven yet. The lower city of Mohenjo-daro, to the east of the Acropolis we have just seen, is marked by a number of streets also, including this wide, 9-meter wide street. But then it is a more complex layout, a little more. This is just a small part of the lower town. We can see that the planning suddenly seems a little less neat than it did in the Acropolis. Nevertheless, we still have, this is the street we were looking at in the previous photo, we still have a broad north, south, and east-west alignment of streets. You can see that there is still a desire to keep an alignment with the cardinal directions. And there are what seems to be like big blocks between those streets. There are blocks which have been identified. And these blocks actually have individual platforms of mud bricks. They are not just constructed in a haphazard way. And these platforms have specific levels which will allow the whole sanitation system, which we'll see a little later, to work fairly smoothly. So there is a considerable amount of planning which took place. And this is, in fact, more so than in cities of ancient Egypt or Mesopotamia, where usually only the area which was immediately around the pharaoh's palace or the king's palace in Mesopotamia had some form of planning, but otherwise the rest of the city at large resembled more, what our modern Indian cities may look like. And, if you look at most Indian cities today, they're just not planned. They're just villages that kept growing and growing in an organic fashion. And you cannot make out a perfect geometric grid as we could do in the Acropolis and to some extent here also. This is a view of Harappa, where Harappa is a very complicated story because it was actually mined for its bricks in the 1850s, long before it was identified, long before it was understood to belong to a Bronze Age civilization. These bricks were so attractive. They seem to have modern, I'm coming back to the bricks a little later, they seem to have modern proportions. And the British railway engineers who were laying a railway line between Multan and Lahore needed something, for their ballast. And in Punjab and Sindh, you have almost no sources of stone. So they found this big mound which had millions of bricks, and they started mining them. They in fact laid a small railway line to evacuate the bricks from Harappa towards the railway line which they were constructing. And as a result, of course, they destroyed much of the city. So there are big gaps in the understanding of the total layout of Harappa. Nevertheless, it's been under excavation by many archaeologists, including successive teams of American archaeologists, who have brought out a huge amount of data. And what we can see here is that it's not two regions as at Mohenjo-daro, but a number of mounds. There are at least 1, 2, 3, 4, 5 which have been identified. There might even be some more further away. And these mounds had their own separate fortified enclosures. So the exact relationship between them is not yet fully understood. They had their own separate gateways also. In fact, I think that I will have one picture of a gateway to show you later. But this is a close-up of the so-called AB mound here, where you can see the type of fortification enclosing the mound. And this is facing, in a way which we will find again very shortly in India, this faces the riverbed, and this is what is known as a recessed entrance, which allows, it's a narrowed entrance into the fortified area, which allows control, basically control of, possibly for defensive purposes, but mostly for the movement of trade goods. Trade goods coming into or out of the city. It is with such narrowed entrances that you can easily control what's going on. But then the question that people have asked is why have fortified cities at all? And because, once again, in many parts of the world, cities have happened without any fortifications. So why should Harappans be so keen on fortifying their cities? Many theories have been put forward. One, of course, is that they were used as defenses. And this is how, in fact, Mortimer Wheeler, who first identified those fortifications here, as soon as he joined the Archaeological Survey as its Director General in the 1940s, I think 1946 if I'm not mistaken, or 45 perhaps, he declared them to be defenses. And then he conjured up a whole warlike context. As you can see here, this was called a citadel, not an acropolis, which is a more neutral term. The point is that perhaps some of the Harappan fortifications were intended to protect against raids by local populations or distant wilder tribal populations, possibly. But the fact is that there has never been any evidence of this at any Harappan site. There's no evidence of man-made destruction anywhere, no evidence of warfare of any sort. It may yet come up in future excavations, but as of now, Harappan civilization seems to be strangely unwarlike. There are very few weapons. There are no specific weapons of war, no depictions of scenes of warfare the way you have, all over Egyptian temples and palaces, etc. So this purpose is actually being questioned by a number of archaeologists. Protection from floods in certain situations where you have rivers like this one. This is the Ravi River, I forgot to mention. The Ravi is a tributary, of course, of the Indus, or at Mohenjo-daro, of course, the Indus itself. Some of these rivers may go into spate, and the fortifications could have, in some of these locations, protected against the floods. Control of trade, I already mentioned. And then more abstract, perhaps, but yet real purposes, like the need to define the urban space, the need to declare that this is the city, you see, and this is our urban space. Or even further, as a symbol of authority. You see, we don't have any symbol of authority otherwise in the Harappan world, the way we have the Pharaoh's palace again, or the Great Pyramids and so on, which are really symbols that stand for the greatness of the Pharaoh. Perhaps this is the way by which the Harappan rulers were expecting to be, you see, understood, recognized, acknowledged. So these are some of the discussions going on. This is in Harappa, an enormous building. We'll see its proportions later on. Actually, it's 50 meters in length and 40 in width. So the largest Harappan building to date, all of these platforms are something like 15 meters long, and yet we can't pinpoint its purpose with any degree of certainty. Again, it was declared to be a granary, but recent careful analysis of the soil have shown absolutely no evidence of storage of grain at any time. So it's a mystery. Was it a kind of community hall or assembly hall? Well, any hypothesis is as good as another. This is one of the gateways into Harappa. The worker at the top gives you the scale, so very narrow as you can see, and clearly it tells us that there's a desire to control, to exert some control. And very often in some of these gateways at the entrance, some of the Harappan weights, which I'll show you in a later slide, have been shown, and those weights were used in the trade. So we can picture some of the guards, sentinels, having a scale and weighing goods which are coming in or out. Platforms have been found. These circular platforms are famous in Harappa, but the exact purpose again is unknown. Initially, they were thought to be used for husking grain, or perhaps having a mortar here. But this also has been questioned. They could also have been used as platforms for dyeing cloth. Again, these hypotheses are not fully answered. Now we move to Kalibangan, which is a small city, smaller, let us say. I think it's about 12 to 13 hectares, if I remember well, on the Saraswati River, or Gagar, as it is called, in northern Rajasthan. And here you can see the same design as at Harappa. As far as the upper part of Kalibangan is concerned, you can see the recessed entrance facing the riverbed in exactly the same way, and a kind of inclined parallelogram. Exactly why were they not having a perfect rectangular shape is not clear. There is also the same angle here at work, even though the streets within the lower city here are at 90 degree angle. So we have an echo here of Harappa, but together the two are a good repetition of Mohenjo-daro, because we have this dichotomy between an upper and a lower city. So obviously the rulers must have been somewhere in the upper city, but then there were other things which we cannot fully understand. For example, here, huge platforms in the lower part of the upper city, no habitations. The habitations are in the upper part and in the middle, in the lower city. What were these platforms were used? Well, all kinds of answers, such as rituals, ceremonies have been proposed, but these are again hypotheses. This is one of the streets in the lower town of Kalibangan, which I was showing you on the map. This is the widest, and here strangely we see another desire to impose norms, standards, some idea of planning. You can see that there are minds at work who had a great love for order, who perhaps would not have liked the kind of chaos we see in some of our modern Indian cities, because here the streets were actually normalized, standardized to specific widths, which obviously are growing in multiples. You see 3.6, 5.4, 7.2 are multiples of 1.8, which is the narrowest. So this is quite remarkable, because you might say it is not at all an indispensable feature, but these people obviously believed in imposing certain such norms. Kalibangan also is known for this particular house, which has where we have its owners indulging in the luxury of having those flooring tiles. You see huge floor tiles of terracotta with the typical Harappan design called intersecting circles, which we will find on pottery and other artifacts. And this is also remarkable, because obviously it is a superfluity of life. It is a kind of luxury. It's a sign of a certain economic affluence. And those terracotta tiles were quite well baked and very, very well laid also. Otherwise, they would have been broken by usage, but they are still in quite good condition. Banawali, there's not much to say. This is a site on the Saraswati again. The Saraswati flows here. It's a site which unfortunately has not been much excavated, only partly, but yet we find here a different kind of layout. So you see there are variations. The Acropolis is here, this kind of semi-oval shape, whereas the total city is somewhat squarish. So there are variations in the town planning. It's not as if the town planning is strictly imposed in every case, but then there are enough features from city to city which are quite recognizable, including the drainage system, but this I will come to a little later. In Banawali, an interesting structure which the excavator Dr. R.S. Bisht suggested was used for some kind of fire worship, because within this altar here, there was no room for habitation. You can see again the worker giving you the shape, the scale. And this semicircular altar was full of 1 foot thick of ashes. And just ashes, no bones, for instance, which would have been the case if it had been used for cooking purposes. So, and then this, you see this apsidal, as it is called technically, that is to say semi-oval, this apsidal shape within an apsidal shape is something quite intentional. This is made of mud bricks. The whole building was made of mud bricks. Only, of course, the lower layers remain now. So we continue our brief travel through this civilization with Lothal, which is actually, this is wrong. It is not exactly in Saurashtra, just on the border of it. It is south of Ahmedabad. And this is a small site, but of great importance because of its famous dockyard. I'll return to it in a moment. You have here fortifications enclosing the city, or the town rather, and this is the Acropolis, or upper part of it. And we can probably suspect that the rulers would have been living in this complex here. The rest is a lower town consisting of all kinds of habitations, small workshops, various manufacturing units. And, but then this is in fact an artistic reconstruction of the, not exactly to scale, but we can see this dockyard where boats, probably much smaller than this one because the whole dockyard measures something like 223 meters, were coming to receive goods stored in this warehouse. So let me show you very briefly. This is another photo of the dockyard, 217 meters in length. Even today, it can still store water after the monsoon. And its walls were made of fired bricks, baked bricks of high quality, though they are disintegrating fast nowadays. And the whole town was on this side of the dockyard. The dockyard was identified as a dockyard. There was some controversy. Was it really a dockyard for boats to come from a tributary of the Sabarmati River all the way up here? Or was it a kind of simply water storage facility? But in that case, such a huge reservoir for such a small settlement would not have made much sense. In fact, the point is that marine organisms have been collected from the sediments at the bottom, and therefore there is a proven contact with the sea, plus the fact that the walls are vertical. There is, if it is a water reservoir, as we'll see in Dholavira very soon, you would expect steps leading down so that you can go down to the water level as it recedes. This is not the case. And then spillways here at both extremities, which seem to indicate a control over the water level. So all these points together seem to argue in favor of the dockyard. And then this is the warehouse just next to it with specific platform, different platforms of bricks, over which the goods would have been stored. And this design is perhaps both to increase ventilation so that the goods will be better preserved, as well as perhaps simply for ease of loading and unloading. So this is known to be a warehouse because at some point it caught fire. It must have had, as most Harappan buildings, a superstructure of timber and some kind of thatching. And luckily for us, during this fire, more than 60 Harappan seal impressions, not the seal themselves, but impressions over lumps of clay, were actually accidentally burnt, baked by this fire, and therefore well preserved. And these would have been used to seal rooms within the warehouse, or perhaps even directly consignments, bundles of goods being shipped away. This is a view of the street in the lower Lothal, called by the excavator the Bazaar Street. And now we move to one of the most important Harappan sites, Dholavira in the Run of Kutch. This is in the highly seismic zone that Professor Matthews was showing. I think it is zone 5, if I'm not mistaken. And in fact, there is evidence by about 2700 BC, the archaeologists who excavated this site, Dr. R.S. Bisht, we excavated from 1990 onward till about 2003 or 4, he found evidence of destruction by earthquake at about 2700 BC, after which the city was gradually rebuilt and enlarged. So they did not abandon the site because of the earthquake, but they actually improved upon it. And here we have not a division into 2 parts, but a division into 3 parts. There is an upper city, middle, and lower. The upper is here in blue. There is a so-called castle, which is a heavily fortified area. We'll see it a little better later. And a bailey with lots of habitations. The rulers, again, are probably residing in this so-called castle. It would make a lot of sense from an architectural point of view. And it's on a higher ground also. And then you have here the middle town, with enclosing also a huge ceremonial ground of something like 285 meters in length, which is a flat ground with a plastered ground. It was a kind of a pink clay plaster which was applied all over it, and stairs on both sides, actually platforms creating stairs a little bit like this auditorium so that people could sit at different levels. So what exactly was happening on this ground? Well, we can use our imagination, some rituals, some sports, or some games, or some marketing, melas. We don't really know, or perhaps all of them. The middle town had most of the habitations, and there were some more here in this part of the lower town, but all the rest of the city was used for water storage. I'll come back to that in a minute. Let me proceed with a few pictures of Dholavira. This is actually a reconstructed view of the castle seen from the northern side. It might have been something like that. Of course, the whole top of the fortification has gone, so this is just a conjectural reconstruction. But you can note the massiveness of these walls. They reach a width of 19 meters of thickness, up to 19 meters in thickness, which would be probably a little more than the width of this hall, or something like this. So this is just the width of this hall. Why exactly such thick walls? If it was purely for defensive purposes, you don't need this kind of thickness. It's not necessary. There can be many explanations, including possibly the rulers having their residences right on top, because it would be much cooler exposed to the breeze than if they lived right in the middle. This is actually proposed by the excavator, Dr. Bisht, and it makes a lot of sense. I forgot to say that the walls, these fortifications walls, this is another view, actually have a core of mud bricks, but both sides will be built with massive stone. This is stonework because there was a stone quarry a few kilometers away from on this island in the Run of Kutch, and stone constructions are not seen in Sindh or Punjab because, as I said, there's no stone at all. But here, because it was available, the Dholaviran engineers made the most of it, and most of the foundations were laid in stone. So we have, for the fortifications walls, we have a core of mud bricks and 2 flanks of stonework, which you can see here. at the northern gate of the castle, you can see the kind of massive construction there. It's quite spectacular. There's no other Harappan site that can give you this kind of massive construction, especially in stone. The castle is there on the other side of this wall, so people would have been coming in and out this way. And here in this is a sentinel room, which is carved out of the thickness of the fortification wall. And in this particular sentinel room here, a huge inscription of about 3 meters length was found, consisting of 10 signs, 10 Harappan signs, the famous Indus script, still undeciphered, or rather there's no agreement on a number of decipherments. And each letter is about 33 centimeters in height, if I remember correctly. And in fact, the dimension of these were a kind of mineral material which was embedded in a wooden plank. Now, the wooden plank has disintegrated. There's almost no wooden remain at all in the entire Harappan civilization, unfortunately. And this material remains, but then the dimensions suggest that it might have been, this might have been a signboard hanging right over this northern gate of the castle. And this is very important because it's the only such inscription of this size in the entire Harappan world. All other inscriptions are tiny thing on Indus seals or a few signs on pottery. And therefore it suggests that, this is one old debate, how much of literacy was there really in the Harappan world? Was the script the property of a kind of elite? If this inscription was really hanging there for everyone to see, it suggests that at least some people were able to read the Harappan script. So these are the kind of mysteries that remain. This is another sentinel wall within the eastern wall of the castle, and you can see again massive stonework, but you can also see these pillar bases. These square forms are pillar bases, highly polished and perfectly regular. This is a feat of engineering in itself. And then you have what are now understood to be pillar segments, some of which are also lying here around, which would have been piled up over one another and until they reach the roof. And this is a very interesting design because Dholavira gave us the answer to some of those ring stones also found in Mohenjo-daro, but they were not understood in the Mohenjo-daro context. In fact, it's now proven that the Mohenjo-daro ring stone actually come from Dholavira or the Kutch region, because this is the area where they were mined. And so the usefulness from a structural point of view, in fact, we would need the advice of experts here, but there are, of course, many advantages to such design. One is that you can assemble pillars of various heights at your desire. Another is that, for transportation, it's much easier to transport shorter segments than a huge monolithic pillar. Professor R.N. Iyengar, in fact, proposed another hypothesis, which we would have to study, which is that perhaps these would be more earthquake resistant than a monolithic pillar, because with lateral motion of the ground, a monolithic pillar might be apt to snap at beyond a certain intensity, whereas these segments would move relative to each other, but perhaps the pillar might not collapse. I think this would have to be, you would have to do some modeling about this, Professor Thomas, and tell us whether this hypothesis can hold. These are some of the streets in the middle town of the Dholavira. You can see once again this concern with planning, geometry, order, streets at neat 90-degree angles, and these are all the habitations on both sides with stone foundations. But the actual building, the actual houses would not have been built with stones. They would have been built with mud bricks in this region. Mohenjo-daro is almost entirely built with baked bricks, probably because of very high water table in Mohenjo-daro due to the proximity of the Indus River. So the Harappans there wanted to minimize infiltration of dampness into their habitations, and therefore they used baked bricks. But here, this is an extremely arid climate. Even if it was slightly less arid, possibly in Harappan times, they were not really bothered by such problems, and therefore mud bricks were just as good for habitation as fired bricks. This is another view, one huge complex, housing complex in the middle town. And let us, in fact, have a few words quickly on construction techniques. This, I have already spoken of the Harappan bricks, and you can see some of them here at close-up. And you see they have these modern proportions that our bricks today have. That is to say, the width is twice the height and the length is twice the width. Now, they were so modern, in fact, that in 1914, one scholar attached to the Archaeological Survey of India visited the site on the advice of the director, John Marshall, and he saw those bricks there lying around, but they did not conduct any very deep excavation. And he said, you know, judging by the bricks, the site could be 200 to 300 years old at the most, because this is what the bricks were saying. So he could not, it's only 7 years later, 8 years later, that the correct age was understood. Now, the advantage of those bricks is very simple, that you can, as you can see here, when you have successive courses, you can have one course lengthwise and another widthwise, and if you want to have a very narrow wall, that will be quite enough. Just one brick widthwise will do. And this is known in masonry as the English bond, which I propose should be renamed the Harappan bond. But you know, the English have a habit of claiming a lot of things. Anyhow, this was assembled only with mud mortar. There was no lime mortar there. And of course, the bricks were not left exposed as you can see them here. They were covered with mud plaster, which has long disappeared. So this is one problem which archaeologists are facing, that especially in Mohenjo-daro, how do you conserve such walls after leaving them now exposed to all the weathering taking place? And in fact, the Mohenjo-daro bricks are suffering a lot because they were never meant to be exposed like this, you know, for decades together. They were protected by a mud plaster, which unfortunately we cannot recreate so easily. In fact, I should have said briefly that you see these multiple layers. What looks like different layers are not different stories. You can see the difference in height. They are simply different levels of reconstruction of the cities as it gets flooded by the Indus. And when the Indus floods, it deposits huge amounts of sediments, which it has carried all the way from the Himalayas. So the Mohenjo-daro builders, strangely, rather than try to evacuate the sediments every time, preferred to actually rebuild their habitations on higher and higher grounds. This is what this photo seems to say. This is a design of typical Harappan house with a central courtyard and rooms organized around it. And this is actually a design that will live on, that can still be found in many traditional houses in rural parts of India because it's so convenient and well adapted to hot climates in particular. This is one photo of a very large house, a single house in Mohenjo-daro, where you can see multiple rooms. But let me rather show you this plan, because one lady, Anna Sarsina, an Italian scholar, long ago did a meticulous study of all the house plans and found that actually there were 5 types of them, and basically not more. There could be variations, but basically there were 5 master plans for the houses, which were repeated on and on. And these, she has classified and she has given the specific details for each of them. You could, you know, almost call them BHK1, BHK2, something like that. It's not exactly the idea. It's not purely size, but this is how it works. The largest have this central courtyard around which all the rooms are organized. So even in the types of housing there is, somebody has kind of given a standard to be followed, at least in Mohenjo-daro. This is quite remarkable. That means nothing much is left to chance. In fact, there is even a debate now as to whether this stupa, which dominates the Mohenjo-daro Acropolis, here you see the great bath, which we will turn to in a moment. This stupa was all the way supposed to be a stupa, that is to say a Buddhist monument over the Acropolis. But now there is new thinking by a few scholars, including Michael Janssen, the German archaeologist who worked at Mohenjo-daro for many years, that this might be a Harappan construction after all. So you see, there are lots of, what I want to say is that there are lots of unanswered questions and still a lot of room for exploration. These are some of the pillar segments at Dholavira, which I was showing you in a sentinel, in situ, in a sentinel room, but these are carried out of the site. And you can see how pillars of various heights could easily be assembled. And you can see, of course, the diminishing diameter of the pillars. So this is a very simple, efficient pillar design which they were using at Dholavira. Talking of construction, we have to make a mention of what I think we could qualify as an invention, that is to say the Harappan, the circular well. It's an invention because though it looks obvious enough at first sight, there's nothing very obvious about it. This is at Mohenjo-daro, and as I said, at Mohenjo-daro the water table was very high. So one result of this is that you get massive underground infiltrations, and there will be pressure on the structure of the well. And therefore, if you use plain rectangular bricks, what's going to happen is that the pressure is going to push some of the bricks inside, and then they will fall into the well, and little by little your structure will be weakened and everything will collapse. So the solution which the Harappans found, no doubt by long trial and error, was to use not rectangular bricks but trapezoid bricks, as you can see here. And those trapezoid bricks clearly are going to lock together when the pressure of the infiltration comes. So this is, it looks so obvious and simple, but it's extremely smart. And even 2,000 years later, the Romans, who were excellent hydraulic engineers, had not found a solution to this problem. And they were still building big wells, generally square in shape, which used to collapse. Some of them would collapse inward from time to time and had to be rebuilt therefore. So this is where we can appreciate the expertise, technical expertise of the Harappans. In fact, though some in the later, this is from much later, 2,000 years later, in India, some of these trapezoid wells still survive in the Ganges civilization. The dominant well becomes the well of terracotta rings. And you can see here from Rupnagar in near Chandigarh. This one is from Mahabalipuram, so a very different period and different. So obviously it has come to us in the south from the north. And the advantage of the ring well is that, well, of course, that ring wells can be built from the top. The rings are going to, once you have done a basic excavation, your rings are going to move down with the weight and you can keep adding to them from the top. So it's a very safe way to build a well. You can't do that with a brick well. A brick well has to be built from the bottom. You can't build it from the top. So that's the difference. So the Harappans, what they did was that, and this is from Kalibangan, they of course had a huge excavation around. They made a very big cavity, which is a lot of work. If you consider that Mohenjo-daro had an estimated 700 cylindrical brick wells. And here what we see, and it's very interesting, is that they built from the bottom, as I said, which with a high water table must have created a lot of difficulties. We're not really sure how they did it. But then they also, before closing this huge excavation, filling it back with mud, they created these buttressing, supporting walls so that the structure would be very solid. So they had a certain sense of, the strength and weakness of structures. Sanitation is a hallmark of the Harappan civilization on a much wider scale than in contemporary cities, again like Egypt or Mesopotamia. And interestingly, it comes actually from it is visible in a few sites even before the phase of urbanization, which, as I mentioned, begins about 2600 BC. This is about 200 years earlier in Kalibangan, where we can already see a neatly straight street with some drains of baked bricks running alongside. So this is even before the urban phase. So we can see that some of these inputs must have matured much earlier. And well, typical view of the so-called municipal drains of Mohenjo-daro. You have individual bathrooms in these houses here beyond this wall on the left, and you can see all the individual drains taking the dirty waters out of these bathrooms and joining into the municipal, what I call municipal drain here. This would all be common. This is a street, and all of it would be, of course, covered. This would be underground, you see. It has been excavated now so that we can see it. And there would be openings, kind of manhole covers or slabs at regular intervals, because you see, it's very nice to have a drain, but if you don't have a force to maintain it regularly and clean it, it's going to be clogged in no time at all. So Harappans were aware of this, and which is why we can say that there was some kind of a municipal force to maintain the drains. And, but then what's remarkable from an engineering point of view is that Michael Janssen, this German archaeologist whom I mentioned earlier, has measured the slopes of the drains, and he found that they are 1 to 2 centimeters per meter, more or less all over the city. So this means a tremendous amount of calculation, planning to make sure that the initial levels and the lower levels are going to allow this kind of a slope. If you visit my city of Coimbatore, any substantial rainfall will cause all the drains to overflow because they don't have a slope. So you see, these are problems which we are still grappling with millennia later. A quick view of how it would work within a house. This is actually one house here, and you have a private well. Some of the wells in Mohenjo-daro were private, some were public. And you have the bathroom here. So by bathroom, of course, we should not picture some of our luxurious bathrooms. These are modest bathing platforms, but still almost every house in Mohenjo-daro and Harappa had such bathing platforms. And this internal drain takes the dirty waters below the boundary wall. And you can see the very nicely adjusted curve with all this is made of baked bricks. And you can see here a sump, you see, so that the purpose of the sump is obvious. It is meant to allow any solid matter to drop down there, and for maintenance of the drain, because here this is a lane, this is a public lane, then it's going to be much easier. So you can see the amount of thinking that it takes, and to ensure again the proper levels, and so that the water can flow. A quick view of a typical large house of Mohenjo-daro. I'm showing it only for one purpose, because it happened to have a pipe of terracotta, segments of terracotta assembled together, vertically embedded in a wall. Now this is amazing and totally unexpected, because it shows that there was some water activity going on the first floor, and it must have been probably a bathroom. So the conclusion would be that the owners of this house probably lived on the first floor, which is advantageous because it would mean a lot less dust and noise. The streets in Mohenjo-daro were not paved. They were just covered with mud. So the whole city would have been pretty dusty. And probably the servants would have worked in the ground floor. More such slides. I can move a little faster. This is from Lothal, where you have a series of 12, we see only a few, 12 bathing platforms connected to this perfectly straight, nicely constructed drain made of baked bricks. These are more drains in the lower town, taking probably the flood waters away from the. And then the latrines. Latrines were not studied much in earlier phases, but recently in Harappa there's been a whole study of latrines, and they were found to consist mostly of a kind of a commode, which these are the foundations of the commode here, where people sat, and there was a soaked jar here to receive everything, and then a water pot for washing. So, but then you please consider that this was available in almost every house. So this shows the degree of importance that Harappans attached to hygiene and to a certain sense of order. Water management is one, perhaps my last but one area I would like to cover. Can I have another 10 minutes? This is about very early structures, some of which are found in Harappan times. We cannot, strictly speaking, call them Harappan. They are from Balochistan at that time. They are called Gavar Bans. They have a very long history afterwards. And these are so ingenious that I could not resist showing them. You simply have a stream there flowing down from the Balochistan hills. And to do agriculture, for good, efficient agriculture, what you simply do is to terrace a side of the stream and make it fairly horizontal, but then in a way that, you know, the water will gently invade your field. Now it means, you know, these must be very lazy farmers, but very smart also, because the water is going to, of course, irrigate, plus the stream is going to drop its sediments and therefore fertilize the field automatically. So these are very efficient, low-cost water structures from but you need a good slope and, of course, a good stream. Now back to Mohenjo-daro with the grade bath. We have a better view now of this basin, which is about 12 meters by 7. You can see again the very nice brickwork. These are all pillar bases. The whole structure might have had again a superstructure of wooden beams. And here we have some 12, if I remember well, individual cells where perhaps, well, these are assumptions again, just hypothesis, perhaps priests or people conducting rituals would have been, changed. There is a well also which would have been used both for filling the tank as well as for ablutions, etc. So the exact purpose of the grey bath remains a little bit debated. Initially it was thought that this was a public bath, but then when archaeologists started finding individual bathrooms in almost every house, they realized that there was no need of a public bath, and therefore this is thought rather to be for ritual purpose, some kind of religious ablutions taking place there. This is a plan of it published by John Marshall. You can see the entire complex. We were standing in the earlier photo, we were standing somewhere here. And you can see that this is the well filling which would have been used to fill the basin. But then how to empty it? Well, it had a drain, a huge, in fact, underground drain going out in the north southwest corner. And this means there must have been some kind of a small sluice or some system to, to close this drain. This is the outlet of the drain a little further down. And you can see, in fact, here a better view of it. This is the drain. And you can see that this is what is called technically a corbelled drain. Corbelled because you have different levels of bricks till they join. Now, I'm just making a small reflection here from an engineering point of view, which is that I always wondered why the Harappans did not invent the true arch, because actually they had it. This is nothing but the principle of the arch, but it was horizontal. It never occurred to them, to flip it vertically and use true arches vertically, where instead they use corbelled arches. To my knowledge, the earliest true arches in India date back to the 1st or 2nd century AD. You can see them in Koshambi, for example, on the Yamuna. But the Harappans did not know the true arch. Few words on water management at Dhoravira. I showed you the plan, but I forgot to mention that the whole city was bracketed, you might have noticed, by two little streams. These are actually small seasonal streams. You can see the bed of one of them here. And the intention is quite deliberate and obvious. It is to divert some of the water from those streams right into the city in those reservoirs I mentioned. And this is done by constructing a series of dams. You can see here the remains of one of these dams on one of these channels or nallas, if you prefer, which would be filled only seasonally. They would be dry most of the year. Today, if you visit, you will find them carrying water only during the monsoon. So this is one possible way to use these stone structures on each side and close them with series of what is called a palisade. There could be other designs too. We cannot be sure. And ultimately, this is how the city might have looked like during a bountiful monsoon, where this is, these are the two streams, you see, which are bracketing the city, and whose waters are brought into the city. And there are there's a series of reservoirs are here, plus a number of man-made reservoirs, which I'm going to show you in a few minutes. This is another view, of course, computer-generated. And we know that there are many important water structures within Dholavira. These are tanks in the castle area, which therefore would have been used possibly exclusively by the rulers. What's interesting here is that all of these are connected by underground drains. There is a wide network crisscrossing the castle, bringing water harvested from various parts of the castle into these tanks. So water harvesting is done in a big way. There is also in the castle this huge stone well here, and it's about 6 meters in diameter. And well, this is not at all the well of trapezoid bricks, and it would be susceptible to inward collapse, but since we are in a very dry region, there's no such fear. The underground infiltrations are going to be weak at all times, and this is why the well survived for hundreds of years. This is from the top of the fortifications, the castle fortifications, where we can see here a strange, highly polished, big stone slab, and actually it is part of a structure which is meant to channel whatever rainfall would hit the top of the fortification walls, channel it into a kind of funnel shape all the way into those underground drains which I just mentioned. So very sophisticated thinking, planning, and execution to make sure that basically not a drop of water is wasted. This is a view of one of the underground stormwater drains in the castle. You can see that this is another one. This is actually Dr. R.S. Bisht, who excavated the site in the 1990s. This lady gives you the scale of the drain, all built with massive stone, big stone slabs covering it all. And you wonder, because in fact, this is going to be empty most of the time. So what message this gives us is actually a climatic message. It tells us that the Harappans were expecting massive rains once in a while, you see, especially of course during the monsoon, but possibly at other times, and they didn't want to waste any of it. So therefore they built those enormous drains, even though the average rainfall is extremely scanty. So it's not a question of average, but it's a question of capturing the peak rainfall. This is in another part of Dholavira, one such underground drains, which you can notice simply by the top covering slabs, and this manhole cover. So this manhole allows somebody to go into and clean whatever needs to be cleaned. Now, apart from the sequence of reservoirs I showed in the earliest plan, there were some man-made reservoirs very close to the castle. And this is the colossal eastern reservoir. You can see the dimensions here for yourself. It's enormous, almost as long as a football ground, and something like 20,000 cubic meters at its peak. There are three stairways leading down into it. You can see two of them here. And in addition, there is a curious structure known as a step well. At the bottom of it, this is it here, but you can't see it today anymore. It's partly covered. Which is intriguing. Was it made at the same time as the tank, in which case it would be a kind of an extension of the tank, of the reservoir, or is it a slightly later structure is hard to say. But this is one, possibly the earliest step well in India, of course, of simple architecture. This is a reservoir carved in stone, and you can see the amount of work this would represent. It's 33 meters long. It's actually a double reservoir. There's a secondary reservoir within it, and I'll come back to it in a minute. And all these reservoirs again are interconnected with underground drains. The advantage of it, obviously, is that if for any reason one reservoir happens to be full or even to overflow, it can pass on this excess of water to the others. So it's a chain of reservoirs, strictly speaking. So you can see that there's a considerable amount of thought given to how to make this city in the Rann of Kutch, which today has no city whatsoever, livable through the year. You know, when you might have no rainfall apart from the monsoon. And well, they tackled the problem, and the city stood for something like 600 to 700 years. So they were able to really adapt to this difficult environment successfully. Finally, a few quick words at metrology and proportions, which strictly speaking are part of civil engineering. I will not say much about the series of weights that the Harappans were using. This is for trade, control of goods and so on. It followed two systems. The first weights, starting from 0.86 grams, followed a geometrical progression. You see, every successive weight was twice as heavy as the preceding one. But then instead of continuing this series, the Harappans switched to multiples, 10 times, 100 times, or 1,000 times the previous weights. For some reason, we don't really know why. So this means that also they were familiar with, the concept of multiplying by 10 or 100 or 1,000. But more important to us today are some concepts of proportions which I want to expand upon. But before I do that, I want to show you this curious object from Lothal. I don't know whether they've been found at other sites, which the purpose of which was unknown initially. It's made of shell, and this actually it turns out to have been a compass. This is a system by which Harappans were measuring angles, and every slot is exactly 45 degrees removed from the previous one. So you can lay this on a flat surface, and you can actually take alignments with a high degree of precision. So this is one of the tools they were using. They must have been using a lot of wooden tools, but we don't have those. Now, about proportions, back to the Mohenjo-daro Acropolis, and I'll just take five minutes to conclude. There's something peculiar about Harappan town planning which I have not touched upon. It is not only a sense of order, geometry, etc., but also a sense of proportion. The upper city of Mohenjo-daro here is about twice as long as it is wide. So that doesn't, that is not very impressive. But when you start looking at the other structures in this Acropolis, you find that all of them obey strict ratios and precise. And there's a very, very low margin of error on each of these ratios. So therefore, there is here a kind of a desire to implement some sense of order, but it doesn't stop there. Even individual buildings, like this one from the lower town, has exactly a proportion of 5 to 4. You will see that this 5 to 4 or 1.25 ratio is particularly important. And this is, in fact, reproduced in the so-called granary of Harappa. You can see the kind of ratio we get. There's almost no deviation from 5 to 4. So why exactly were they doing that? What's the idea? It's very difficult to answer, but there is obviously a sense of, auspiciousness. Some proportion is considered to be more auspicious or perhaps more beautiful than another. rather than leave things to chance. You know, somebody who designs, for example, this auditorium is not going to be bothered about, you know, the ratio between length and width. But the Harappans were really bothered. And it goes on like this. Lothal also has 5:4 if you take the middle point here quite precisely. The dockyard is exactly 6:1, and etc. And Dholavira is the most striking of all because it has 5:4 exactly for the castle. It has very, very precisely 5:4 over the entire city. The margin of error is 0.01% for the overall city, and that's 771 meters in length. So why were they doing this? You know, it takes a lot of labor, additional effort, which actually has no utilitarian purpose. It doesn't make any difference whether you have this ratio or something else in actual practice. Then you have also exactly 9:4 repeated twice between the length of the castle and that of the middle town, and once again 9:4 to the outer city. 6:1 is for the ceremonial ground, the same ratio we saw at the dockyard of Lothal. So you can begin at 7:6 for the middle town. We can begin to see something going on, and it continues even for the reservoirs. There also they did not believe, you know, in leaving things to chance. They wanted to impose strict ratios. So this is exactly 5:2, and here we have also ratios of 7:2, 11:4, etc. So I did a little study, in fact, I published a few papers on this, where I showed that every major structure unearthed so far obeyed one of these ratios. And you could be falling between some of these simple fractions, but you do not. You are always right on a simple fraction. So there is a philosophy here behind. Is it exactly something similar to the later concepts of, I insist on the word later, of Vastu Shastra? Some people rush to say that Harappans were following Vastu Shastra. No, I don't think we can make such a claim. But it is true that in Vastu Shastra, you have this concept of proportions given. For example, Varahamihira says that the quarters of the king, the length should be equal to the width plus 1/4 of the width. Now, width plus 1/4 of the width means that the length is exactly 1.25, 1 1/4. So that's 5:4. That's the ratio 5:4 which we have found here. And you see, it's there in many traditions of India. For example, the builder of the Jantar Mantar observatories, you know, Jai Singh, the Maharaja Jai Singh, his title was Sawai Jai Singh. What does Sawai mean? It means exactly 1 1/4. So this tradition is, you know, a notion of increase. You add a quarter because it's considered a sign of growth, perhaps expansion. And finally, I played around with the numbers and calculated what could be the likeliest unit of length that the Harappans used to design Dholavira, and I found that the unit of 1.9 meter gave beautiful numbers all around, but this is a detail, we can leave it for the time being. I think I will just skip those details, except that these are the ratios for all the reservoirs, and I found that my unit, even at short distances, short length of reservoirs, was giving almost perfect results. So anyway, let me skip those details. They are rather secondary. The point is that we find a sense of order and a systematic use of proportions and possibly linear units in the Harappan world. Even small units like this angula, but I will leave these details for your later study. It doesn't matter much for today. I want to conclude on a remark that this standardization on town planning, as I showed, it's not a rigorous standardization, not that all sites follow exactly the same plan, but the concepts are shared between all the sites without doubt. A certain standardization of sanitation, of construction techniques, for example, the brick proportions are all over the sites identically. So this means that there must have been, either there was an almighty emperor who imposed all these standards, and it seems quite unfeasible with the area of 1 million square kilometers, Or rather, and this is the present thinking of many archaeologists, there must have been communities, communities of builders, communities of town planners, people we might call architects today, just as there were, of course, obviously communities of potters, of seal makers, of craftsmen, and therefore this might be the mechanism by which these concepts and standards were shared, allowing some variations regionally, but nevertheless very efficiently and remarkably shared over the entire region, which is how we can identify those sites are sharing one common culture. So in the end, this is what Gordon Childe, the famous Australian archaeologist, wrote in 1952 after decades of explorations in a book called New Light on the Most Ancient East. And he said, India confronts Egypt and Babylonia by the 3rd millennium BC, of course, with a thoroughly individual and independent civilization of her own, technically the peer of the rest. Though again, Harappans had no pyramids, they had no glorious monumental temples, etc. And plainly, it is deeply rooted in Indian soil. The Indus civilization represents a very perfect adjustment of human life to a specific environment, and it has endured. It is already specifically Indian and forms the basis of modern Indian culture. So this is just a quick overview of Harappan genius in the area of civil engineering. I mean, many more contributions of theirs could be highlighted in other fields, but I think this is good enough for a start. As I said, many questions remain unanswered, and there is still a lot of room for future archaeologists to work on and a lot of sites for them to work on. Thank you very much.
No, what I wanted to know was it jointed with a particular material? Were the joints filled with the material? Or did it slip one into the other?
I think they slip into one
into the other.
I think so, because I remember seeing in Dholavira the mouth of some, of course I cannot swear that this is the case in Mohenjo-daro, but of some of these terracotta pipes was broader. So obviously they were meant to fit into each other.
Right. And the other question I had was on the reservoirs. Was the bottom of the reservoir as well lined with some material that prevented percolation?
No, apparently not. The largest reservoir in Dholavira, the bottom has not been reached, in fact. So they're not very sure, they're not excavated right to the lowest possible depth. Okay. Of course, in the case of the rock-cut reservoir, then of course there's no question. The bottom is rock. Right. But it's quite likely that the earth mud reservoirs, if you like, the bottom were not particularly lined, and it was allowing therefore percolation. Okay. And well, if you have a well in this reservoir, then it makes sense, because you'll be recovering that water later on. If your reservoir ever becomes empty, you still have this well to draw water from. And this design was repeated in the historical era much, much later in the Ganges Valley. There are sites like Shringavirapura on the Ganges, where there are chains of reservoirs, and each reservoir has a well at the bottom. So perhaps the idea comes, that of course we cannot.
And were these reservoirs of, I mean, a sort of a diminishing size, so they could collect water and...
Here in Dholavira, not particularly. There is no such regularity. They were just adjusting themselves to rock surfaces which were there. Okay. So we cannot say that there was any particular such order. And the eastern one was massive. On the southern one, there was a row of 5 or 6 reservoirs. Possibly a few more may lie unexcavated, but there's no such sense of sequence.
And my very last question is, the mounds that you mentioned of mud bricks on which the settlements were raised so that to prevent from flooding of the settlements, were the mud, I mean, was the mud reinforced or anything so that it would sort of withstand flood waters?
You mean in Mohenjo-daro, perhaps? No,
not in Mohenjo-daro, but in Harappa, I think you mentioned the mounds of mud bricks.
Mohenjo-daro and Harappa faced the same situation, in fact. And these mud bricks were actually sun-dried bricks. You see, when we say mud bricks, we shouldn't figure that they were very malleable, not like that. They were hard, but not as hard as the fired bricks. But they could be good enough especially if you are going to raise an entire platform, it will be extremely wasteful to do it with fired bricks. There will be a certain structural strength of its own. So then mud bricks will do. But then when you build a house, you don't want to see it, melting away due to, not only due to flood waters, but also due to the dampness that is going to be rising through the capillarity of the bricks.
Here.
Thank you so much.
Next. Here.
Sir, did you find difference in characteristics of the clay all over the area? And can you just throw light on that?
Excuse
Say
me,
the type of the soil
characteristic
in the
of the
area. Type of the soil around this big area, how it was different from place to place, one. And how about the strength of this bricks? Was it changing from place to place for used to use? Anything, any ideas on that?
Okay, well, the second question, I'm not aware of any good, mechanical test done on the Harappan bricks. They were found to be of high quality, that is all we can loosely say, but I don't think any systematic comparison on the quality of bricks has been made. Of course, in the case of Mohenjo-daro, Harappa, Haryana also, you see these are all alluvial plains. So you get fairly good quality clay material.
What do you mean by good quality clay? What do you mean by that?
Which is deposited by those rivers. So if you see, for example, if you travel in those regions even today, for example, Ganges Valley is full of brick making factories, full of them. So they just use the alluvium, which has a certain content of clay and silt, both.
Silt, that's all.
Both. But I'm not aware, to be honest, of any systematic. We need engineering studies on all these aspects, absolutely. These were great alluvial plains, and that is the kind of soil environment they had. A site like Dholavira is totally different because it's on a rocky island in the Rann of Kutch, so the geology is totally different. There's nothing to be.
So both fire bricks and sun-dried bricks both are used there?
Yes.
Okay.
Next question. Anybody else? Yeah. 1 minute, sir.
The dimensions which you have indicated, does it have any relationship to gaj, which is 3 feet? When you multiply most of the dimensions, it is equivalent to 3 feet, multiples of 3 feet. Is there anything connected like that? Have you found out anything like that?
No, not exactly. You see, I didn't want to spend too much time on the question of the linear units. I personally found a unit of 1.9 meters at work in Dholavira, but that has to be confirmed through statistical studies.
Which may be 6 feet. Which may be 6 feet.
It is a little more than 6 feet. It's 1.9 meters. 6 feet would be 1.81 meters. So maybe there is something, but I find that actually the basic unit would not be the foot, but a unit around 21 centimeters. And there's been, if you look at the old excavation reports, there's been a lot of talk about an Indus inch and an Indus foot. But actually there's been no real study trying to correlate most of the Harappan dimensions, real dimensions, to those units. It doesn't seem to work very well. So we're still at the beginning from that point of view. And it could be that there were many units, because see, in ancient Egypt, for example, there were at least a dozen linear units at length. Even if you take the cubit, there were at least 2 cubits in ancient Egypt. So there can be several systems at work at the same time. It can be quite complex. So we would have to really make a systematic study.
The second question is this, the structures with all the floods you said, they are all being maintained well, being kept well. Is it because that the mortar they have used is very strong, or the bricks themselves are, even though sun-dried, is very strong?
No, I think it's more because of the bricks, quality of the bricks, number one, but mostly this mechanical bond which the proportion of these bricks allow you to have. In the Ganges Valley, 2,000 years later, this proportion of 1 to 2 to 4 is abandoned for some reason. They don't use it anymore. And if you visit any of the Gangetic sites, you will see, like Nalanda, Koshambi, any of these, you will see much more squarish bricks and flat. They don't follow the Harappan proportions or our modern proportions at all. So these proportions that the Harappans were using gave great structural strength to their walls with a minimum of material. You see, that's the advantage of it. So I think these are the two reasons. The mortar was just mud mortar. It would not have great strength of it on its own.
But generally the bond gives you strength and compressive strength on the top, from the top. But what about the side erosion and side push by the river?
See, they would have been damaged, and we have actually evidence of damage due to flooding from time to time in Dholavira. Lothal was destroyed by floods completely once. Archaeologists can trace these things fairly reliably. So it's not that everything was, hunky-dory and structures were perfect and lasted forever, not at all. But they were always willing to, reconstruct, and sometimes even when there was a catastrophe, it would signal a new phase of expansion. So that was the dynamism of the civilization, if you like. But structures were certainly vulnerable to the environmental conditions, there's no doubt about it, including earthquakes.
Thank you, sir.
Any other question?
Now, what is the cause for the Mohenjo-daro and Harappa become the center of the civilization in those days?
Excuse me, what is the cause?
What is the reason why it has been developed as the center for civilization?
I have not understood.
Some X and Y places are there. What made it to become like that?
Well, you could answer by simply saying, why not? You see, if there is a convergence, there is a long evolution in this entire northwest region for thousands of years earlier, right from Neolithic times, and at a number of sites, well, not too many, but some in Balochistan and one or two in Haryana, cultures going back many thousands of years have been identified. And with the continuous evolution towards so those cultures were actually Neolithic, they were even in pre-metal ages with just stone technologies. And we see a gradual evolution. And it's, what is very important is that there is a building up of networks of trade right from Neolithic times. That means 7000 BC. You find, like for example, Mehergarh in Balochistan has shell artifacts made of shell, which are found 100 kilometers away on the seashore, of course. So these networks are what bring people together, these trade activities. And well, cultures keep evolving, and then metallurgy comes in. It's a whole new technology which allows for rapid expansion. Then agriculture is developed. With agriculture, you have a surplus of food at some point, which is a critical condition for cities to be established. So exactly why does it happen at a certain time, nobody can really say. There is probably a kind of critical mass that has to be crossed for cities to emerge. In the Ganges Valley, it will happen only in the first millennium CT, so 2000 years later. So there also, why? You have to it's only by understanding the entire evolution of regional cultures that you can answer, but even then partly, there are many things which are still unknown in our knowledge, to our knowledge.
Last question. Yep.
What caused the end of the civilization? Is that what you are asking? Very brief answer, there is a multiplicity of factors at work. Long ago there were theories that invaders came and destroyed these cities, and you find that still in some of our textbooks. But the simple fact is that archaeologists have never found the slightest bit of evidence to support that. So they've abandoned this theory. Instead, they concentrate on environmental problems. There are two especially, but there could be a multiplicity of environmental factors. One is that all over the world, or much of the world, from 2200 BC onward, there is a considerable drought happening. It is felt in Mesopotamia, it's felt in Northern Africa, it's felt in Northern America also, even in China. And this is a 200-year-long drought. Of course, there must have been rains from time to time, but it's suddenly severe aridity setting in. And this has altered patterns of agriculture over much of these regions. So this could be one reason, because cities are heavily dependent on agricultural surplus, right? So if that disappears, you see, cities may have to be abandoned. Then there is another factor, which is this Saraswati river I showed you in the first map, which was certainly supplying water either directly through its main channel or through a multiplicity of side channels to some 360 sites in this region. And it seems to have dried up about 1900 BC. This is the evidence from a number of archaeological sites like Kalibangan, for example, is totally abandoned. It was right on the Saraswati. It's abandoned overnight, not exactly overnight, but maybe in the span of a generation or two, around 1900 BC, we have radiocarbon dates. So in that case, it means that if you map the evolution, I have that in another presentation, of the settlement patterns in this region, beyond 1900 BC, all the settlements in the central Saraswati basin have disappeared, all of them, which means that the river has dried, basically, at least in its central portion. So this would have been a very important factor. But which factor took place before the other? Archaeologists also talk of social disturbances, they talk of disruption of trade with Mesopotamia. All of these happened, but exactly in what order today, nobody can safely know.
We'll take the last question, and if others have questions, please stay back and have a personal discussion with Professor Danino. Last question. Yeah, madam, your last question. Please, mic, please.
Is there any evidence of human remains?
Oh yes, plenty. There have been, I'm not sure the total figures, but it runs into hundreds of skeletons collected from various sites. In fact, most sites, not Mohenjo-daro, but Harappa has 2 cemeteries, Dholavira has 1, Lothal has a small one, etc. Almost every site has got a cemetery where some skeletons have been found, but you have to keep a few things in mind. First is that many of the graves have been found to be empty. For example, Dholavira, 63 graves, only 2 have had a skeleton. All the other graves were just empty. So they were symbolic burials. And secondly, even if you total up all the skeletons found in all the sites and you multiply by 10, assuming, or even by 100, assuming that we have missed out a lot of skeletons and some have disappeared, etc., you still have a very, very small proportion of the total population which would have inhabited all these cities over 700 years of the civilization. So therefore, the main means of disposal of the dead must have been cremation and not burial. So that raises very important questions which we cannot answer again. Who were those who were buried and who were those who were cremated? You see, there might have been some social difference. These are 2 big questions. We don't have enough evidence, strictly speaking.
Dear friends, at the end of this talk, I'm sure all of us will share my view that we'll be even more proud as Indians after seeing the accomplishment of the Harappans of ancient times. And spectacular town planning and building construction techniques that we saw leave us quite astounded, and it makes us peep into the intellectual prowess and achievements of the Harappan mind. I wish, like a TV anchor, I could, call in one of the old Harappans to come here, or download one of the Harappans and make him sit here along with Professor Danino and ask him all the unanswered questions. Since that is not possible, we should wait for our archaeologists, younger archaeologists, to do more research and come up with the answers for more. I think you have raised more questions which are unanswered than answered, including why the civilization died. So once again, on behalf of everybody present here, and personally, Professor, thank you for giving us a peep into our ancient civilization. And I'm sure all of us will carry wonderful memories of this talk and motivate us to read and think more about what our ancients had achieved. Thank you very much.
Thank you, Professor Matthews. Thank you, Professor Danino. I have the pleasure of proposing the vote of thanks. I think it was a fantastic journey that took us about 5,000 years back in history. On behalf of the National Center for Safety of Heritage Structures and Department of Civil Engineering, IIT Madras, extend my thanks to Professor Danino, who almost immediately agreed to come here and deliver this lecture. He was in Gandhinagar conducting his course and had to go back to Coimbatore yesterday to cast his vote and then come here to deliver this lecture. So thank you so much from the bottom of our heart. As a token of appreciation from the NCSHS and Department of Civil Engineering, I request Professor Matthews to hand over a small memento from IIT Madras. That's a unique memento from IIT Madras, from the campus.